Hi, my name is Angela Fitka, and this is my final project for Physics 3030. Originally, I wanted to talk about the different particle eras after the Big Bang, but after learning about them all, I found I was most interested in the Planck Era, the very first one. The Planck Era occurred between 0 and 10 to the negative 43 seconds. Scientists can only theorize about what it was like during that time by studying what came after the Planck time, when the universe grew to the size of the Planck length. From that, scientists can extrapolate that during that incredibly small window of time, the universe was smaller than an electron, infinitely dense, and hotter than anything ever would be again. So, where did the Planck's length come from? Max Planck. He was working on calculations designed to predict the color of a heated object. The color of the heated object would glow depending on how hot it was. The calculations wouldn't work with the current idea of energy, so he began to think it might not be right. He wondered if energy could be expressed in incredibly small but discrete units instead of a continuous stream. His hunch was correct, and he found out that energy at the subatomic level is transferred in small units called quanta packets. This discovery led to Planck's constant, which put the quanta in quantum physics and gave rise to many equations that helped explain the quantum reality. So why can't we measure anything smaller? James Stein gave a good analogy using water. Think of how you can only divide water up so many times until you reach a water molecule. Dividing beyond that and it isn't water anymore. We can't study anything smaller than the Planck's length because beyond it causes physical theories to break down. Length and point of location lose meaning as quantum uncertainty blurs it into a range of possibilities. Cool, huh?